So we're going to talk about the nth term test for a divergent series. So just a little fact. So when a series converges, then a sub n, so that's like the sequence of its terms, they converge to 0. So the nth term test for divergence says a series diverges if the limit of that sequence fails to exist or if it's different from 0. So this actually is a really easy way to tell with a lot of series if they diverge or not. Some can still be tricky, but if I have something just like this series of summing up just n, right? So this would just be like 1 plus 2 plus 3, so on and so forth. Okay, so logically you probably have a sense of like, yeah, this sum will not converge to anything, right? Because it's just growing all the time. But you do need some way to back that up. And so having this theorem here, that's how you back up that reasoning. And so really what you can say here is the limit as n goes to infinity of n, this equals infinity. So the series diverges. So there we go. Okay, so what about this next one? So now I have another sum. So I have 2n plus 3 over n. So if we're not sure, we can just use our old limit techniques. And I can really break this up into two separate parts, right? So that this becomes the limit as n goes to infinity of 2 plus 3 over n. And so if I just dissect the parts of the limit, this part here will go to 0, but 2 is just going to go to 2. So this equals 2. So 2 does not equal 0. And so this also diverges. So if any of these went to 0, we would have to do more work to prove its convergence. But as long as this is not 0, it diverges. So it's that simple. This last one's also a really classic one as far as divergent series goes. So as a limit, as n goes to infinity of -1 to the n plus 1, this actually just does not exist, right? Because it's really just bouncing back and forth to 1 and -1. So this limit just does not exist because of just how it keeps bouncing back and forth. And so since the limit does not exist, then we know that the series diverges. Let's say, so the series diverges. So yeah, so this is a really quick and easy test to determine that. But the one thing I want to reiterate here, so in the event that this limit does equal 0, this is not enough to prove convergence. So this is only for divergence. So as long as this fails, as the limit fails to exist or is different from 0, it's guaranteed to diverge. But just because it equals 0 does not mean it converges. So just want to be really clear on that. Okay. So this was just a short and sweet video on that particular test. So I'm going to leave it at that, and I'll catch you guys in another video. Bye.